Welcome back, dear friends, to another exciting episode of making the Unplanned Steampunk unpowered arcade machine. Yes, as you all know, I thought by this time, this is the fourth episode it will be, that we'd have got tons done and be working on gameplay and all that. But obviously it's not quite been the case. I can't believe how complicated it's proving. I suppose I should really, because once you remove elecmatrickory from the equation, everything is so much more difficult, just having to rely on gravity and momentum and things like that. So this is where we've got to so far. Here's the cabinet I made. Where's the ball thing? Oh, here's the cunning device that holds a ball, a steel ball and a coin and things, and allows you to raise that handle up to the top. That's connected via a ball chain to a counterweight here, just that simply allows the chain to be pulled up. As you lift that, a ratchet clicks round, then you let that go, and I want it to go down slowly, because then it'll have enough energy and time to move parts of the game mechanism. And I have tried using, I thought was a very clever idea, having a motor such as this one short-circuited, so it acts as a generator that's then generating electricity that basically is trying to turn it in the opposite direction. They do work as really good brakes. I mean, electric cars use them, regenerative braking, you know, it's an effective thing, but not in this case. It sort of started working once I'd got 200 teeth there and 10 teeth there. It started, but not good enough. So that's the stage we're at the moment, and I remember wittering about using an escapement, a mechanical escapement, last time, early on in the last video when I was editing it. I was thinking, why on earth didn't you start with that? I think it's just because I don't know anything about them. Obviously I don't know anything about using motors to slow things down either, but live and learn. So today's exciting project is to make an escapement. Lovely XP computer, still working. Now I looked online to try and find a CAD drawing of an escapement, and I couldn't find any. There was one, but it had bits missing. So I went to Wikipedia, and they had a little animation of this. I can't remember what sort of what sort of movement it is, but I basically turned it into a JPEG, dropped it onto the CAD software, traced around it as best as I could, and recreated what I hope is the correct geometry, because obviously they're very complicated things. So I'll get that cut out. I've added an escapement. Here it is, and there's the pendulum, because obviously I don't want a pendulum hanging down the front, but I could, if necessary, if it all gets overly complicated, possibly could extend the back and then have a window so you could see a pendulum swinging and things. But look, this is fascinating. Just by moving that, it is actually turning the escapement, which I assume, nearly, every time I put the camera on, is probably a very good thing. So I now need to put some weight down there and give it a go. What's this? Is it radioactive? Dare I touch it? What is it? It's lead for flashing round chimneys against roofs to stop water leaking in. It's brilliant stuff, although now it's classed to be so deadly dangerous that you can't possibly even touch it without getting brain damage and things, apparently. I think it's classified as there's no minimum dose that isn't harmful to you. But I grew up in a house built in the 1930s that had its water main made of lead pipe, as did all houses in those days and prior to that. And in the mornings my mum would switch the tap on and the water would come out all milky, and she contacted the water board and they said, oh, don't worry about that, that's just lead oxide that's sort of leached into the water overnight with it sitting in the pipe. Just run the tap for a couple of minutes first thing in the morning. Yes, never did me any harm. Anyway, what was I talking about? Yes, lead weight. So this, I ordered this because I want to make the weights for it properly. I need to establish exactly how heavy to make the counterbalance. Focus! Why? And how heavy to make the weight for that. I would have hoped it would have started oscillating, but no. Right. Another failure, chalk it up. Ugh. It's sometime later and I've got another pendulum. Different shape. I haven't worried about strengthening it or anything. I just want to see whether you can see it there. Yeah, well, there's the shape of it. It's a funny little hook thing. But this time, and I'm not worrying about driving it with a chain, little steps. But this actually is working. And also I've realised that with all the normal clock movements, the escapement is actually driven off a very geared down, because the weights turn the hour hand or something like that. That's where all the force is. And then obviously that's geared down to 60 times smaller for the minutes. And then the seconds, which have the escapement, is another 60 times, the 1,200 or something. Just when you think, why on earth do I do these things? Can you hear a ticking by any chance? This is so exciting. This is why I do this sort of thing. Look, it's working. I cannot tell you how thrilled I am. It's going very slowly, obviously, because if that's 10 teeth and that's 200, so that's 20 to 1 or whatever. But it's working. The principle is working. Sorry, I'm getting all overwrought here. You can see it slowly turning round and the chain is slowly dropping back. First of all, I have considerably shortened the pendulum, and it has correspondingly speeded up. So that's good. Obviously it is still too slow because the chain is going through really slow. So my next job, rather than reducing the size of this one, I'll just add more teeth. In fact, I think I've still got them left over from the first experiment. So I'll add a 20 tooth gear on there and we'll see what that does. That's exciting, because it shows that this can cope, and this is only out of 3mm thick for the test, so I can make that out of 5, which will be far more resilient. And I've also, now I've seen it operating, I've got a far better understanding of the description of how it works. It's very nicely designed to reduce lots of force on little delicate bits. Right, it's just snapped one of the prongs off, or whatever they're called with escapements, and I'm not surprised because it was whacking backwards and forwards so fast. And this is very thin. This is what it was like on the animated drawing I got it off, where someone was obviously more interested in the engineering than what it looked like. So I've redesigned it to make it thicker and stronger, and I can cut it out of 5mm acrylic. Thank you so much for keeping all of the comments and suggestions coming in. They are invaluable. I'm very grateful. Thank you for your effort and hard work. I checked them last night. That's fantastic. In fact, at the end of this video I will list all the contributors. So thanks very much. Keep the comments coming. I haven't even started thinking about the gameplay yet, but the good thing about doing it this way is that once I've got this all sorted out, this mechanism and the lifting and the coins and the balls and the this and the that, it means I can apply that to any sort of game, all sorts of different types of actual gameplay that's going to go in there. Ooh, beautiful sunlight. Thank you whoever pointed that out that I'd commented on last time. So that's really well worth it. You can do it. You can do it. Perhaps I can. Oh, welcome back. I haven't done any videoing for several days because it's just been one failure after another, and whilst everyone enjoys failure, there is a limit really to it. I shut my eyes and I can see escapements. I take the dog for a walk and I can see escapements. I go to sleep and I dream of escapements. Escapements, you say? Yes. Mind you, I have finally had some luck. I say luck due to the ignorance that I bring to the equation, because I'm so sick of looking at these things with their reflections. These ones did work, but they kept getting stuck. So then I decided to add some PTFE, which I luckily had floating around, to the pools, or whatever they're called, to try and reduce friction, and they didn't. But it didn't stop me, because I made about 6 different pairs of pools, all different shapes, and they didn't work. Then I happened to try my original escapement on it, and it did sort of work, because I had filed down These ones had little sharp corners there, little pointy bits, and these ones I filed round because I thought that might be where the friction is occurring. It was. It worked. So if we lift this up, and I'm not going to groan as though I'm some aged whatever that can't bend down. Right. That's nice, and it doesn't get stuck. It goes right to the bottom, and obviously I could slow it down by lengthening that or putting a heavier bob on it, good old bob. But you can see how slowly that is now descending. So that's nice. And you can see the beautiful escapement working. Now the great thing about this, because I was thinking the other day, I realised that actually once you've lifted this up and the ball thing is up here or on its way down, if the ball goes out of play because you're not very good or made a mistake, you don't have to wait for this to slowly sink back to the bottom. You want it instant. You want a shorter pendulum, or possibly none. So let's take the pendulum off and see what it does. By the way, the pendulum won't be hanging down in front of the game. I just want to get all this working. This is sort of experimental stuff, because then I can work out all the different layers and how best to add everything, and the pendulum could hide it behind it and all that sort of thing, which I think I did mention. Right, pendulum removed. Let's give it another go. Oh, it's so easy to bend down. Ah, that's wonderful. So we need a way of connecting and disconnecting a pendulum run entirely by the force created by a steel metal ball, such as these ones, and rolling down some sort of slope at the bottom, which signifies the ball's out of play, that's pivoted at one end. So as it goes down, it creates force, which then pulls something, which then pulls something to do this. Idea one. I'm saying it's one, because I'm sure it's not going to work. We've got a brass thing there. Let's lift this out. We've got a brass thing there. This is connected to the pendulum. And we've got this bit that's connected to the escapement. And if I put the rod in, drop it in, under gravity it drops into a little hole in this, and then the two are linked. So, try that. It doesn't work. Look how much slop there is. Oh dear friends, I think I might have actually achieved it. It's a second version of the second version. Let me show you. Here's the first version of the second version, which I've taken apart so you can get a better idea. Right, there's two pieces. This piece goes onto the pendulum so it can rock slowly, and it has a little pin you can pull up with a piece of string. This one fixes onto the escapement, so it whizzes backwards and forwards. You'll see there's a little slot. So when it's in the centre, the pin can drop and align it. If you lift the pin up, then the escapement one is free to whiz past very, very quickly. I've made that the lighter one so it can move quickly. That's slightly heavier. I've made some improvements because I realised very quickly that I'd got it wrong again. And here we have it. Well, you can see there's the centrepiece, the first part that's glued onto the escapement that comes down here, that's got the nothing in it, and then the piece that is glued currently onto the pendulum very badly has got the thing with the slot, and also look, there you go, you can just see, just pulling that up and down, that had slotted in. So let's give it a go. This is the, what I call it, litmus test. Everything works perfectly until I film it. So we lift that up and they're engaged, so that's going down nice and slowly, working the main pendulum nice and slowly. Then if I pull gently on this, look, it rattles down to the bottom and then stops, and then I release the string and it's just dropped back in, because releasing the string would be controlled by that steel ball that's rolled into the trap at the bottom. Oh, I say, and then it's then released when the coin slides down. That is a major achievement. That has opened up the gateway to the next part of this wretched project. Oh my godfathers. So the next job, whilst walking the dog, is to think about how the whole scoring system is going to work with this big dial on the front. Come on then. That's it. Let's go for a lovely walk. Well, I'll ride the bike and you run along with your mouth in a huge smile. Dog walked, and I've just had a fantastic idea. Best ideas come to me when I'm walking the dog. Now for the scoring, obviously it's got to be mechanical, so I think it was Ibrahim again, very kindly, who sent the suggestion of using a clock dial, possibly with units, and then the tens on another little dial that can obviously be linked together, and that's lovely. That every time that goes right the way round, not to turn that side, that counts one more. And I was thinking about this in the park, thinking, well, I can run it off the ratchet mechanism, and it can this, that and the other, and it can whatever. And it was getting so complicated because, of course, once the ball goes out of play and releases this thing and that whizzes round, if it was linked to that directly, you know, even though you've lost, suddenly your score would whiz round really fast. No good. I was thinking of all sorts of complicated mechanisms and things. And then it suddenly came to me, the fact, what is happening, what is only happening while the ball is in play. Even if you lift the thing again, because the ball's still in play, what is happening? And I realised, of course, it's this pendulum is moving, the big one. And that's fantastic, because that means while that's rocking, it counts up the score. If you release it, because the ball goes out of play with that, this one stops rocking, stops swinging. I was so pleased. There's always lots of complicated ways of achieving or solving a problem, and if you're lucky, you come across a simple way. So if I have some sort of lever on the pendulum shaft, that can just be turning this while the big pendulum is moving. If the small one whizzes down to zero, it won't affect it at all. Oh, I can't tell you how exciting this is. It's lovely because I can visualise it in my head. I can see that it will work and how to make it work with a little counterbalance, counterweight on the hours and minutes, on the tens hand, so that when it's released somehow, that is another mechanism, it will then just whiz back to zero when a new coin is put in. Oh, it's just lovely. It's so fascinating having to think about this in terms of mechanics rather than lines of code, because they both sort of have to achieve the same thing, but in such different ways. It's lovely. This very morrow, whilst walking the dog, I thought, this is probably going to be a good place to stop this video. All I need to do, just to round it off nicely, is to make a cardboard cutout of the scoring system that I mentioned previously, I think, and simply make the ratchet, get that working, the scoring thing. It's a nice place to finish. 5 hours later, as always, never learn. I have finally, I think, got it working, but sans cardboard bits. Let me show you, but it's exciting the way it works. No expense spared, we have a background. So this is the new ratchet thing, version 3 or something. This is how it's going to work. So, as the pendulum swings backwards and forwards, it rocks this, which has fallen off. And this, oh, every time I switch the camera on, it's got a pawl here that pulls this ratchet round. Where are my fingers and thumbs? And another pawl that just hangs against it to stop it, acting as a ratchet to stop it going backwards. And I'm going to have a weight here, a light weight, so that when I release both of these, when the score needs to be reset to zero, the weight just whizzes round, resets the hands. And I realised in the park just now, walking the dog again, that I was getting concerned about it slamming into the stop at the end at zero when it was whizzing around really fast. And then realised, of course, I don't need a stop. If it stops with the weight hanging down vertically, it's fine. It'll whiz round and then just swing back to zero. It is very exciting. Let me see if I can demonstrate it. So, I will lift the lever, and then when I let it go, look, the ratchet is advanced by 1 notch each swing of the pendulum, which is fantastic. So I can gear that down now, and then that can be moving the pointers on the scoring device. Now it's on the same shaft as the other one, so if I release it to do the quick release thing, it all goes horribly wrong. Sort of. But that's just because it is on the same shaft as the escapement and hasn't got a counterweight on it. There comes a time though when it is time to finish a video. So thank you very much for watching. Thank you for your continued support and all the ideas. I'm going to put a list of all the contributors of ideas up at the end of this video, because I really am grateful. There have been some brilliant ones. Oh yeah, and I forgot. Tomorrow we're celebrating my wife's 50th with a Disco Inferno and karaoke evening. So time for some tidying, which is no mean feat. I'm just going to do it tomorrow. I'm not going to worry about it today. Anyway, thanks again. Hope to see you next time.